Good evening, everyone. My discussion today is going to be about an application of AI towards sustainability and classification of waste. This is a classic problem in machine learning and artificial intelligence, and techniques have gotten very developed in recent years. My project mainly aims to demonstrate more of a practical application of this towards a real problem that a lot of us face, which is deciding where things go in recycling and waste allocation in general. The global recycling crisis is one of the worst it's ever been yet. Recycling has a 25% contamination rate. This means that 1 in 4 pieces of recycling cannot actually be recycled. It's thrown in there due to a lack of knowledge, a lack of education regarding what can be and what cannot be recycled. This contaminates the entire batch, as once the garbage is contaminated by something that's non-recyclable, you cannot recycle the entire thing. Or it requires intensive extra processing, which leads to higher costs, and a lot of the time for recycling companies, it simply becomes infeasible for them to pursue this. The annual cost of this then is $300 million lost by these waste management facilities because of this contamination damage. They are forced to invest in newer equipment or spend longer time processing a batch, which hurts their profits and means that they are unable to effectively deal with this contaminated recycling. To put this into perspective on how it affects our daily lives, 1 in 4 items are misplaced. They are incorrectly sorted and contaminates the entire batch. This is not the issue of any one consumer. It's more of a societal issue where people on a global scale do not recognize what can and cannot be recycled. There's simply a lack of education or um, lack of resources when it comes to determining what can go into the recycling versus what needs to go in the landfill or what needs to go in composting. And so because of this, valuable resources that might end up being recycled are thrown away. They're put into the landfill and they could have been recycled, but now they're being wasted. And same thing with things that should go in the landfill but are end up in recycling. They are, they're unusable, but now they've contaminated other recycling that could have been recycled beforehand, which also leads to major issues. And so I want us to take a moment and try and think about what we might do to solve this issue. Because this is not really a technological issue or an issue about creating new technology. It's more of an educational issue, a behavioral one, if you will. And so here I've listed some of the current solutions that exist out there. For example, you have the recycling partnership. This uses physical education kits and campaigns. However, this is limited by high costs and reliance on physical materials. You need to mail these kits out or you need to pick them up in person, which is incredibly inconvenient for many consumers that might not be in the area. Second one is the Recycle Coach. This one provides localized sorting rules through municipal contracts. But this one is difficult because it's restricted by needing to partner with the government for proper information, and it requires manual item searching. So if you have an item, let's say an apple, you would have to go and search it up by yourself to figure out whether you should put it in the compost or recycling or a landfill. And then final one is Recycle Smart. This offers state-specific search tools. The difficulty with this is that it's geographically limited, meaning that it only exists in your local area, which makes it difficult for it to be applicable to a wide range of audiences and solve this kind of global issue, if you will. And so this is why EcoWise is created. EcoWise essentially allows you to take a photo of anything that you might be recycling, throwing away, putting it into a landfill, and it will return to you a classification of where it goes, what the materials are, and it will give you some facts about the product. This eliminates uncertainty because it allows you to identify any waste item anywhere, right? One thing that I forgot to mention earlier is another potential solution is by installing sensors at trash cans. This is actually something that I've seen in my own life where trash cans will have sensors that you can scan to see whether it's landfill or recycling or compost. And so EcoWise is essentially a more accessible, more carryable version of this. You can carry your phone anywhere with you, and you've essentially taken the sensor with you. And so this saves immense costs because whereas in the past, you might need to install sensors at every single trash can or disposal location, now you can just have this one app on your phone and take that everywhere with you instead. This immediate guidance is also paired with a robust support system. So EcoWise is not just a classification app for trash, it also educates you on other sustainability topics as a whole. To encourage long-term habit building, we have a gamification system, including points, achievements, and leaderboards, as well as a friend system so that you can friend your colleagues in real life, and you can see how many eco points they're collecting, and that might motivate you to use it more and classify trash properly. And so we believe that this gamification system is incredibly useful when it comes to creating long-term habits because it encourages you to consistently check the garbage that you're throwing away. And the reason that this helps is because if you're confused about a topic, right, and maybe you are not sure where this trash goes, you can just scan it and it will tell you where to put it through its like image recognition system. So I want to talk about a little bit about the technical aspects of this. The mobile client is an app that you can download on your phone, and so then this will handle all the interactions and UI elements as well as the initial image processing, right? When you take the image, we need to do some pre-processing, and then it gets sent to the neural network. And after that, the AI will classify the user-submitted images to identify the waste materials. I'll show you some more slides about statistics on the classification itself because there are some very complex trash items out there that may not be able to be classified seemingly accurately, like multi-material items or like layered items especially. And then the backend of this app specifically is a scalable cloud infrastructure, and it manages authentication, real-time database, and secure serverless functions. So this is mainly to support the ego points, the leaderboard, and the friendship system to allow for more advanced, more robust and secure account login information, for example. So these are the main aspects of the app itself from a technological perspective. Now for the user experience, the main system is that you download the app and then you create an account. When you sign in, this kind of helps preserve your scanning history as well as achievements and friendship, as well as your past ego points, for example. And then the main system obviously is you tap the bottom button to scan. You open your camera, you take a photo, and then it will give you the analysis. And then once you get this analysis, you get disposal guidance. You also earn eco points. You unlock achievements, and there's also fun facts about it to address the underlying fundamental issue of a lack of education when it comes to when to recycle, what to recycle, that kind of thing. And as mentioned before, you can view leaderboards, you connect with your friends, and you can track progress towards sustainability goals. And so this helps promote long-term habits as opposed to just being a one-off thing, as a lot of solutions generally are. So throughout the process, there are a couple of technical challenges that we have to deal with. The first thing being server-validated achievements. Generally, to combat this, we use secure cloud functions, and this helps prevent users from manipulating things client-side while they're logged in, and to prevent them from accessing anyone else's account. And then for the AI classification itself, we need to provide accurate analysis for complex items, and we do this through intelligent routing. of ambiguous cases, which means, like I mentioned earlier, layered products and multi-material packaging. And then the real-time database is an issue because at first we went with like a SQL structure, but this was quite inefficient and not really tailored to our use case. And so we decided to go with the Firestore NoSQL database so that we can ensure that it scales well with the number of users while also having instant updates and robust user profile management. So you can edit your own location, you can edit your information such as your name, your username, that kind of stuff, and it'll be updated in the database to reflect that in real time. So for some validation, we've tested this right on 10,000 voice image items, and it's achieved a pretty high classification rate of 95.8% overall. This is on the entire data set that we used. So for testing, like the data set that we use for testing, and so it's pretty good. It should hold up pretty well in terms of real life settings. And then the performance and scalability. This is the really important aspect of it because when it comes to classifying waste when you're in your day-to-day life, you want it to be as accessible as possible, as fast as possible. And so for us, the average AI response time is pretty fast. It's less than 2 seconds, even under like peak loads. And this is mainly due to our server architecture. It allows us to accommodate tons of scans and ensures a smooth user performance. And then as for the actual user experience as a whole, the technical aspects are quite robust, but the other aspects may not be. However, this kind of shows that it does work, right? The pilot programs with 500 users, they provide critical insights, which led to the user experience that I mentioned earlier, the user flow, their interaction with the app as a whole. And so we have pretty good results on the surveys for that as well. And then as for security as well, like I mentioned earlier, we need to make sure that there's no client-side manipulation of the statistics, the leadership, the leaderboard, or your own points. And as a whole, we do that pretty well with encryption protocols and secure authentication features that will ensure that you can log into your account safely and your progress will be preserved over time. So a little bit more about the front-facing user interface directly, because like I mentioned earlier, we want to promote long-term habits. The first step to that is to ensure usage. The user interface built into this, you need to be treated with a semi-navigable interface so that you can figure out where you're going and deal with things on a more technical level. So the visual theme and styling of this are pretty good. Mainly, it's the goal is to maintain a consistent and aesthetically pleasing interface. So we went with a green theme, mainly because we want to promote images of sustainability and green living, essentially. The rest of our colors follow the same general guideline. We have some lighter colors, and then for our primary colors, for our text, we use black, which is relatively good, or dark gray, sorry. And then, as I mentioned earlier, this UI is especially critical for an app like EcoWise, where the goal is to be used often, right? Is to encourage you to come back again and scan more pieces of trash so that you can really build these habits, right? So that eventually, you'll be able to identify pieces of trash even without scanning it. And so by integrating it into your daily habits, you can achieve long-term sustainable behavior. And then, as mentioned earlier, we did some testing on it. This is a smaller data set for specifically like challenging items, like low resolution or ambiguous items. And it was pretty successful, had a 100% classification rate. And then for the second one, we have the achievement system for backend reliability. So this one, as mentioned earlier, is for the secure backend system with so we tested 17 achievements and it had a 76% uh, reliability rate even under peak load. So this is pretty successful as a whole, but as future developments are made, this number will likely go up. So this testing is important because in general, the app as a whole, you want to make sure that it works well because if it doesn't, then consumers they won't come back. They will be they'll use it once maybe, and then they're going to leave it away, and they're going to go back to their old habits of not knowing where things go, and then they just guess. And guessing, leads to $300 million in extra costs for waste management facilities or 25% of recycling being contaminated. And so we really don't want them to return to these bad habits, which is why we have such a focus on user experience and the user interface as a whole to make sure that it's really reliable and can classify accurately. So now here's a bit of a demonstration just to give an idea of what we're talking about. So here, this is the user interface at the very beginning. As you can see, so these are the lessons I mentioned where you can learn about other sustainability topics. They have information, they'll have small quizzes so that you can test your knowledge. And they're about a wide variety of topics. So if you get it correct, it'll tell you. If you get it wrong, it'll give you an explanation as well. This is the leaderboard. You can sort by global, country, or friends. And then your profile can be managed well. This is the achievement page. You can add friends through a search bar to encourage, keep holding each other accountable. And then finally, this is the main feature, which is classifying trash. So you just take an image, you press the button in the center, you take an image, and then it'll classify. It'll tell you the material, the item classification, and it'll give you some facts about it. As you can see, you earn 10 eco points. So this is similar to the gamification that I mentioned earlier, where we want to encourage long-term habits. So as you can see with this onion, it gives a different classification. And so with these results, I don't know if you saw at the end there, it was a little bit fast, but the 20 eco points that you got from scanning the items, it shows up on the homepage. And so this is really, like I said earlier, to promote this sustainable living. You want to see your eco points instantly. You get the instant feedback of you earning these points, and that builds the habits, like I mentioned earlier, of you classifying this trash to figure out where it actually goes. And so that was just a demonstration. So now I want to talk about the impact of this, right? The technical aspects are generally not very difficult. I think it presented certain challenges, but what's more important to talk about is the impact and the accessibility. In recent years, there's kind of been this shift from top-down infrastructure projects to empowering users and consumers on a more grassroots level. We want to create accessible, user-centric solutions rather than large infrastructure projects to promote sustainability on a wider level. And the goal of this is twofold. First thing is that if you create these products, you can get a larger impact immediately because more people being involved in this change leads to a bigger result. The other issue, or the other solution, I should say, is that by creating these user-centric solutions, you are directly involving them in the sustainability process. And so whereas before sustainability might exist on offshore wind turbines or in large nuclear power plant facilities, now sustainability is in their lives directly. And so we saw this shift with sustainable packaging with paper straws. And now we see it when it comes to waste management with EcoWise. The user can directly interact with waste and classify it to figure out where it goes. And this promotes long-term habits and it makes them more eco-consciously minded, which will enable future solutions as a whole. Because it operates on smartphones people already own and it runs incredibly quickly, this allows these users to essentially take it with them wherever they are, regardless of whether their device is new or old, it runs incredibly fast and efficiently. which makes it highly accessible. This is particularly of importance in underserved communities where these low-income households and rural areas are often excluded from advanced recycling systems or programs due to a lack of funding. Because EcoWise is completely free and runs even on low-end devices, these communities have access to the sustainability tool that they might not have had access to in the past. Finally, the impact is that it addresses the behavioral issues that humans have had in the past with not knowing where things go. By consistently using EcoWise and scanning your garbage, you can enact behavioral change and decide where things go in the future, maybe even without scanning. If you interact with the app enough and you gain enough information, maybe through the lessons or maybe through just classifying pieces of waste. Here are some future plans for the app. As I mentioned earlier, there are many improvements to be made, and this EcoWise app is mainly serves as a demonstration of how this technology can be applied towards practical environmental challenges, and it can be scaled into low-cost solutions. The first improvement is offline functionality. Given that currently the model offloads a lot of the AI classification using offline functionality with embedded lightweight TensorFlow models will allow them to use will allow the results to appear a lot faster because the model will be able to train with common items, and this will reduce internet dependency. The goal is to eventually take the entire app offline so that it can be used anywhere, even if you're in the woods without an internet connection. But to get there, we need to first address issues of speed as well as reliability. And so this will require consistent training with the offline model to ensure that it reaches the same levels of classification accuracy as the offloaded version. The second improvement is location-based rules. Generally, the app will provide you with general guidance as to where trash goes. However, we would like to integrate municipal recycling ordinances to provide hyper-local actionable disposal guidance. And so what this means is we want to provide you with information that might be local to your region. This requires us to draw from city databases and APIs to retrieve the required rules and regulations regarding whether something can be recycled, or if you live in a neighborhood with maybe more or less recycling containers than other areas, you get specific knowledge as to where exactly a piece of trash will go. And then finally, we want to transition to global deployment, which is scaling this product worldwide to transform waste sorting. We want to turn it from a confusing chore into engaging educational experience. Currently, we partner with municipal governments and local farmers markets to classify waste, but we want to scale this onto a global level. We want to encourage people across the world to use EcoWise and learn about recycling and sustainability as a whole to determine where exactly their trash goes and to be more environmentally friendly as a whole, to develop long-term habits and generally structure their lives around living sustainably. And so I think that ends my presentation. I'm open to any questions now. I think we end a little bit earlier. I know it's the end of the day, so hopefully this allows you guys a little bit more time to relax for tomorrow. Thank you.
Thank you, Mr. Brannan. It was a great work. Is there any questions from forum? Is there any questions from forum? I think there is no questions. And thank you once again. Thank you.
All right,
Now
thank
we are
you
on.
for having me.